So there's more details to come on 4DFlib. I'm going to have another video after this initial set describing how to use it. But before we move on, there's still a little bit more to talk about object relational mapping. Mostly that this isn't necessarily a straightforward cut and dry solution in the sense that it may not be applicable in every circumstance. It may not be the right choice for you depending on your coding style and things like that. That said, it is still by and large very widely used, and I would argue in many circumstances it does in fact not only make development more efficient, but it also gives you tools that make your programs better, like we talked about before, the ability to swap out a database. Is that something you do often? Of course not. You may never do it, but one day you never know when that new requirement's going to come up, and it's nice to have the ability to accomplish something like that based on that. And it goes back to what problem are we solving, right? When we think about why we're using this thing to begin with, right? And remember, we're solving that impedance problem. We're solving the difference between the object-oriented world that we lived in, that we talked about last week, and the relational database world. And that's what the purpose of this is, right? The purpose of this tool is to give us a way to adapt information back and forth, quote unquote with speed, but it's really with ease as a developer. So we don't have to constantly be thinking through those relationships. We basically hook up to the database once, and we use this library to then manage all our interactions. Hopefully, I mean, you can circumvent it, but I don't recommend doing that. Once you hook up, you really should be using this library to manage all your transactions. So general advantages, obviously these are things that we talked about, but I want to kind of solidify them into concrete lists. This is not an all-encompassing list. This does not cover probably every advantage. I just want to touch on the big ones. A good object relational management, and the key here is good. There are some ones that, in my opinion, are not so great, can lead to much less code, right? Especially repetition, which we don't necessarily want, right? So if you want to take a layered approach and you are going to be talking to a relational database, which a lot of software does, you're most likely going to be creating some kind of object relational mapping layer of your own, eventually, depending on the size and scope of the project. The alternative is to have your code, your SQL code, so to speak, like the actual queries, interlaced in your service or your controller, or depending on how many layers you have, your business logic in some way, shape, or form. Many people put them in the object itself, and I understand this from a pure encapsulation standpoint, but it's never been my cup of tea. For me, I go by plain old data, plain old Java object, and I understand that you're querying for the data to fill that object. But, to me, that's part of the act of creating an object, creating an instance, managing its life cycle, and destroying it, which historically is something you do, in your actual business logic code, either in a service, ideally, or a controller. I understand that that is a very widely adopted thing. I just don't necessarily abide by that logic. That's a complete aside and has no relevance here. That's just, my kind of take on that as a developer. And if a program is done in that style, again, one of the biggest things that you have to know as a developer is you never refactor for the sake of refactoring, right? I know it's kind of our first instinct. We get some piece of software and we're like, this thing is all wrong. I don't understand why they did this, and I would have done it this way. And I just kind of like spat out an example of that, right? I was like, I wouldn't put my SQL code in my model. And a lot of people do. But the key to remember here is that if I'm hired at a new position and that company has code that exists and that's the way it's done, then you know what? I'm going to adapt to that, unless it's like day 2 and they've got 5 lines of code written, and I'm the lead, and then I'm going to lay down the law. But other than that, assuming this project is duly along, it's important that you remember we don't just go in and like undo everything just for the sake of redoing it, right? That is the surest way to introduce bugs that didn't need to be there. You might, as you're going through, understand 95% of what's going on, but I guarantee you're not going to think through 100% of it all the time, and things are just going to get missed. So never refactor for refactoring's sake. That's one of, like, if any of you guys took me for a programming course or something like that, that's one of the things that we discuss is, like, the golden rules not to do. All right, that all aside, the ORM itself can lead to less code because we're taking all that piece that I just ranted about and we're encapsulating it in effectively use of this library through the library and calls to the library. So now we can have an object relational mapping layer of our own, possibly, or it can still be in the service, whatever makes sense, depends on the scale of the project. And that is talking through this object relational mapping library. All the SQL is being generated there. What you are doing in your object-oriented programming language is still doing good object-oriented programming in that business logic, right? And that is really, really important. And it also means that you can structure your service layer in such a way that you can have it called from multiple places in controllers or wherever. So, if you have, code there to, get users and manage users and do all the business logic surrounding users, updating their telephone numbers and whatever, you can create those pieces of code that are referencing, your database. And then your controllers can just, when they need to update, something on a user, they just call, user.change email address and pass it a new email address, right? They don't really have to think about it. And the layered approach might seem at first like you're adding more and more and more code, but the key here is how big is your project? Because if your project is large enough that you're going to be calling these functions all kinds of which ways from different places, and maybe you're doing a microservice and you can keep it small and you just have an API and that API is going to be your interface. Whatever it is, it's understanding that interface, right? You guys know I love the onion, and computers are just big giant onions, and we get to pick and choose where we want to actually abstract. But understanding how to abstract is probably the biggest thing that differentiates someone who's just a programmer who's just pulling out code and it functions and it does some job, and somebody who actually knows how to architect a system, right? You have to think through all of your possibilities for abstraction and what matters. So I mentioned before, it allows us to change out database technologies. That's really important. That's something that if you had to go back, if you had SQL code in your program, and I've worked with software like this, especially back, I'm not picking on PHP, it's just how things were written more like, in PHP than, say, Java. It's not like a deficiency of the language. I'm not a huge PHP fan, I'll admit it, but I worked with it for honestly, 5 to 7 years, where it was like most of what I did was PHP. You can't, hate your language at that point because you hate your life, right? But what's important to point out is that almost without question, all the PHP software I worked with, and some of it was as small as web forms and simple databases, supporting web forms and simple websites, and some of it was as large as student information systems and other pieces like that. But consistently, there was sometimes model view controller approaches, but at least in the older days, and I know things have changed, programmers who used PHP weren't layering well. And maybe they could have. It wasn't that the library wasn't letting them, but they weren't really doing it. And what happened is you ended up with all this SQL that was written right into your business logic in all these different files all over the place. And let's say you just updated a table, right? You just updated the user table. You were doing greps on your entire code structure just to find where those changes happened. And, it would happen in files all over the place. It wasn't just like files directly related to user because it's such an intricate part of the software that all the other business logic pieces were looking for users too. So now you had to find this thing in hundreds and hundreds of places, literally. I'm not kidding. I remember doing this, and update SQL statements and think about each one so you didn't introduce new bugs. And it's almost like that refactoring thing I was just telling you about a moment ago, refactoring for the sake of refactoring. This wasn't refactoring for the sake of refactoring, it was refactoring because you needed to, but it was horrible. So if you have a library like this and you wrap it correctly with your own code in a nice layered approach, you would have one file to go in and fix that stuff in. One. And that's kind of the key, right? You want to get to that place. I guarantee you it will bite you on a bigger project if you don't. And the other big thing that I haven't talked about yet is that it's more secure, right? So, for example, a library for an ORM will force stored procedures. You don't even have to think about them, right? It only takes like one query that you forgot to wrap in a stored procedure to give a good possibility for SQL injection. Just one, right? You don't want to do that. And, you're going to have probably on a larger project, different developers, and, they all have different skill sets and different priorities when it comes to security. So using something like this ensures that those practices are followed because it's out of your hands. You don't have a say in it, right? So that's really, that adds up to a lot of importance, and it's something that people don't usually discuss on this end, but it really is. It's uniform and it's secure, and those things are important. Some things that are disadvantages here, and these are important, especially newer developers who haven't spent a lot of time doing this kind of stuff. They might not understand what's going on. Their code retakes on that magical, approach where it's like, this just works because I type it, And honestly, as software engineers, I'm not saying like, there's this fine line between leveraging abstraction and, other systems to do our work for us and just blindly doing that. And it's an important distinction because the idea of abstraction and decomposition is that, I don't have to necessarily worry about how my ORM library works, right? Because I can use it and I can leverage it, and that's part of the joy of it, right? And why it's more efficient. And if I had to rip this thing apart and explore its innards, I would be spending as much time doing that as I, maybe would have been doing if I hadn't used it at all, right? So what advantage did I gain? Well, the answer is you might actually lose some advantage on this project. That is completely plausible. But, and here's the big but, you don't have to rip it apart for to endlessly understand every little detail. But when you take on a new abstraction like this, or a new library, or a new framework, I do recommend on project one accepting that you might actually lose some time exploring it, because you get to keep that, right? You get to take it with you. And now you understand, in general, object relational mapping. And even if you go and use a different tool on your next project, your understanding of it is good enough that you don't necessarily have to rip that one apart. It's not, the code shouldn't feel magical anymore. The code should feel like, oh, I know exactly what this code does, right? Under the covers, it's calling this, and it's doing this, and it's creating this. And if you get to the point where you start feeling that the code is magical again, you probably should stop and pause and undo a little bit of that and make sure that you understand why that is working. Remember, in the end of the day, this is all just, ones and zeros, right? It's all just instructions that are, brought down from a higher level language and assembled and linked and created into opcodes, and boom. It doesn't matter what language they came from. At the end of the day, they all do the same stuff. So there's nothing magical. We can always undo it, but that's important. So if you're newer to this stuff, it's worth an initial investment in understanding it. It's frustrating, I know, because you're like, why am I spending all this time doing this? It's supposed to make it quicker. But the honest answer is it could in the future. Especially because you have years ahead of you of building these things, right? So you're going to keep that knowledge, and it is going to make the future projects quicker. But in the beginning, it can be a little bit daunting. The other thing is that the complexity can actually slow down the software. This is something that I'm not going to sugarcoat. It's like anything else. Now, I did just go through my, at the end of the day, it's all assembler rant, but how it becomes that assembler and opcodes, right, matters. And there is definitely going to be a slowdown here. For example, a lot of this happens at compilation time, which is why if you use a framework that somehow is like XML wiring based or something like that, a lot of that's done at compile time, so it shouldn't really slow you down too much. But there's a lot of things that are linked together and a lot of layers, and that adds complexity. And anytime you add complexity, you slow things down. But this is a hard argument to win over time. I mean, you could argue, and you would be right, maybe, and actually I could counter argue this, that if you created your website, and somebody actually did this, and I forgot the name of the website, it was 10 or 15 years ago, I don't know if it's still in existence, in assembler, it would be the fastest website in the world because it's running on that web server, directly as assembler. Well, it looked like shit because it looked like it was 1992. I liked 1992. It was a good year. I unfortunately remember it pretty well. Decent, not great. But that aside, all right, we'll say it was 1996, but whatever. The point is it was text-based, very little graphics, if any. What's the point, right? We've been building this onion of abstraction on top of our computer because it gives us really good benefits. So yes, it can slow us down, but that's one of the reasons why you have to examine what tools you use. I mentioned that before when I said what were the two reasons I actually bothered to make my own object relational mapping software, and the answer for me was that I wanted something that I could go to Java or Scala, or pretty much everything I worked on was on the JVM, and use this thing. And I hated Hibernate. It was just mindlessly complex, and I just didn't like it. And that was, the second bullet really resonated with me there. I also wanted to understand the complexity of what it was doing, so it was a good opportunity for me in, actually creating one to really understand what's going on. And I wanted it also to do the time component, which was a big one. That's a whole new added on thing that the others don't do. So, for me, picking one that has low complexity is important. Even connection pooling, right? There's different tools out there for connection pooling, and without going off that deep end, some of them are considered more lightweight and fast, and some of them aren't, right? So you want to investigate that when you pick your tools. That's important. And also the last thing here, which is important, is complex queries might be difficult to create. So you basically get these out of the box tool set, and that's normal with any library. It's going to vary how much that is. And then you're going to have but I need this, and maybe that isn't going to fit well. So most have and I'm going to show you even 40flib actually has a contributed by one of our classmates actually years ago, has a facility to create complex queries just because it basically gives you the raw ability to create a query. But you're doing this in Java, and it's a little awkward, and it probably takes you, it's completely doable, but it takes you 5 times longer to write this query than it would have if you just wrote the query, right? And once you get used to it, it's a little bit faster than that. But it does, once you get into the, okay, I covered the 98th percentile of everything everyone's going to do, those outliers, it's going to be a little bit more complex. So you do have to kind of weigh how much of that is you, right? Is it just really a couple of outliers, or is it all of your stuff? Because that matters. And there's actually a camp of people that kind of look at ORMs as what they call an anti-pattern. Basically, it's a common response to a problem, but it's ineffective. And this is, not something that is established. It's just there's a camp of people who who kind of believe this. And there's plenty, if you Google like ORM and anti-pattern, you'll find YouTube videos and websites, and there's all kinds of information out there. So I'm not gonna like dive off the deep end. But there are people out there who've been so frustrated with ORM tools that they've basically said, this is stupid, we should just ignore it. I don't think that's the case. I think that in a small program, I kind of agree. Like if you're just, even if you're doing microservices, like you need to evaluate when you're building microservices, you know, how many layers you want in your microservices, because they might be micro in what they actually accomplish, but they won't be micro anymore in how much code is required, right? So you need to think that out. And that's this, right? So depending on what you're building, I don't believe ORM is generally an anti-pattern, but I do invite you to kind of look on the web and explore more on that. And it really does matter, like at the end of the day, it really does matter what library you use. And I'm not even like, I love my own, I use it a lot, but to be honest, it's not widely used, it's not supported really because I haven't been doing much with it. It works, which is great, but I wouldn't tell you to go use it in like a crazy big production application. But if you do want to, and you know, you feel it's strong enough and you're willing to contribute back, I would love that too, because that's how it grows, right? But the way it is now, in the state it's in, it is used in some production apps, and that's great. But you know, I don't want to be like, hey, you go out and use it, and then you come back and like, what the hell? You haven't updated in 3 years, and you'd be right. You know, so take all that into account, right? That's important. That said, if you really like it and you want to contribute, that would be awesome. And you got to evaluate the nature of your own data and the application, what it does, right? And your own abilities, right? All of these things add up to how the benefits, you know, come to you. And on that last bullet, I want to come back around to what I was talking about before. This is really, really important. If you feel your abilities are lacking, I feel the right approach, like I said, is to invest the time to fix that, right? So, you know, you dig deeper into how an ORM works and, you know, however you want that approach to be, and then all of a sudden your abilities are better. So that's how you fix it. And that's how you get more benefit out of it, like I said, in the future, going forward. And, you know, that has definitely played out for me. The initial time I invested in this exploration years and years ago, I now just fire it up and use it, and I don't really think about this stuff too much. And I can honestly say, you know, my interfacing with databases for my software has been vastly improved over where it used to be. It's consistent. I know exactly where to look for problems. I know exactly where to fix them, all those good things. So I do think this has enormous benefit, you know, but I just wanted to make you aware that there's a camp of people who don't necessarily do that. And as always, bring your questions to the forums first, because, you know, this is an online course and I do want the opportunity to answer them there so that everyone can benefit. And I will see you shortly in our future videos.